everyone. My name is Brian Rasadensus and my group mates are Jose Alberto Talia and Rian Pangete. And we are the Group 9 and I am here to present you the Philippines Integrated Stormwater Management. So what is stormwater? Stormwater is water from a storm. Any precipitation that falls from the sky, including rain, hail, and snow, is considered stormwater. There are two ways for falling stormwater. The first is the water falls in a natural landscape without development. Stormwater is absorbed into the ground and falls into bodies of water. This gives needed water to plants and animals and replenishes reserves of surface and groundwater. Next is the water falls in urban landscape, such as impervious surfaces. These are the roads, sidewalks, rooftops, or parking lots, and it is not soaked up by the ground. As a result, the falling water is swept across these surfaces and runoff. This is the graphical interpretation of what happens to the water when it falls to the ground, into the surface, and the ground absorbs the water, and eventually the water will flow to the body of water. And this is what happens to the precipitation when the water falls in an urban city. The water runs on the ground, on the surface, and it brings pollution to the bodies of water. In addition to transporting pollutants, runoff can also cause erosion and sedimentation by sweeping away and displacing soil. It can also cause localized flooding when storm drains take on too much water at once. So how do we avoid this problem? The answer is the stormwater harvesting. So what is stormwater harvesting? Stormwater harvesting is the collection, accumulation, treatment or purification, and storing of stormwater for its eventual reuse. It differs from rainwater harvesting as the runoff is collected from drains or creeks rather than roofs. It can also include other catchment areas from man-made surfaces such as roads or other urban environments such as parks, gardens, and playing fields. And how does it work? First is the collection. Stormwater collection is the process of directing water into storage from stormwater gathering, such as urban runoff. There are two types, and these are the online storages and offline storages. Online storages are conventional way of acquiring stormwater directly from waterways or drains. Next is the offline storages require additional facilities to conduct water from waterways indirectly. For instance, whereas divert low flows into the stormwater container and contribute to a large part of the stormwater catchment for a city. Second is the treatment. The treatment is what mostly hinders the progress of the stormwater catchment. Water treatment process depends on the intended end use and the catchment equipment, which decides the level of and size of the pollutants to be filtered and removed. Generally, the steps applied for different end use vary. For instances such as construction uses may not require high quality water. The water recycling includes only filtration and disinfection. However, for potable uses of higher water quality, the treatment process requires screening, coagulation, filtration, carbon absorption, and disinfection. Next is the storage. There are three factors for the storage: the function, location, and capacity. For function, the planner is responsible for deciding the purpose of the stored stormwater, such as firefighting, industrial water supplies, farming and irrigation, recreational amenity, and flood mitigation. For location, to establish a water tank, an injection system to aquifers above or below the established water below the ground should be considered. And for the capacity, the storage relies on the demand of the end use in a particular climate or period. Lastly is the distribution. There are two types of stormwater distribution. The first one is the open space irrigation system, and the next is the non-potable distribution system. And that's for my report. Thank you.
Stormwater practices. Effective stormwater practices are integrated into the urban landscape to improve their function and performance. There are 12 principles that help define the successful integration of a stormwater practice in the landscape. And these are: first, it provides reliable pollutant removal performance. The practice should be sized so that it captures sufficient volume of runoff and employs a sequence of pollutant removal mechanisms via a treatment train approach to maximize the removal of key pollutants of concern. Second, it mimics the pre-development hydrology. The practice should operate in a manner so as to replicate pre-development hydrology for a range of storm events, such that it safely recharges groundwater, protects downstream channels, and reduces off-site flood damage. Third, it integrates the practice into overall site design. The overall design of the site should support the function and performance of the practice by minimizing or disconnecting impervious cover, implementing source controls, and utilizing better site design practices that reduce the quantity and adverse quality effects of runoff generated by the site. Fourth, has a sustainable maintenance burden. Both routine and long-term maintenance tasks should be carefully considered throughout the design process to reduce life cycle maintenance costs and promote longevity of the practice. Fifth, it is accepted by the public. The practice should be viewed as an attractive community amenity by adjacent residents or business owners as measured by interviews, surveys, testimonials, increased property values, and other yardsticks. Sixth, it creates attractive landscape features. The practice should be an integrated practice designed to be highly visible within the site and serve as an attractive and inviting landscape feature. Seventh, it confers multiple community benefits. An integrated practice should also contribute to other community benefits, such as promoting neighborhood revitalization, expanding recreational opportunities, and educating residents about stormwater. 8. Creatively uses vegetation. An integrated practice not only greens up the site, but also uses vegetation to effectively promote cooling, shading, screening, habitat, and enhance pollutant removal function. The design should also explicitly consider how vegetation will be managed over time to maintain functions and minimize maintenance costs. Ninth, it provides a model for future improvement. An integrated practice is inspected, evaluated, or monitored so that lessons can be learned to improve the performance and integrate future designs. 10th, realizes additional environmental benefits. The design of an integrated practice maximizes other environmental benefits of the site, such as the creation of aquatic or terrestrial habitat, protection of existing natural areas, reduction of urban heat island effects, and other urban amenities. 11th, it reduces infrastructure costs. An integrated practice reduces the amount of paving, curbs, storm drain pipes, and other infrastructure that would have otherwise been employed in a traditional stormwater practice designed within the community. 12. It is acceptable life cycle costs. An integrated practice will not result in high life cycle costs over its useful life.
Good day everyone, my name is Alberto Talia, and I'm gonna continue the report about Philippines Integrated Stormwater Management. Effects of poor stormwater management. Downstream flooding, stream bank erosion, increased turbidity from erosion, habitat destruction, combined sewer overflows, infrastructure damage, contaminated streams, rivers, and coastal water. There are two main issues of stormwater. First is related to the volumes and timing of runoff water. Second is related to potential contaminants that the water is carrying. Advantages. First advantages is it provides proper drainage of surface runoff and avoids damage on infrastructure such as private properties and streets. Second is provides possibility to recharge groundwater and reuse precipitation water and surface runoff as irrigation or household water. Third is minimizing health risk. Fourth, provides effective stormwater flood control. And the last one is can be integrated into urban landscape and provide green and recreational areas. And the disadvantages are expert planning, implementation, operation, and maintenance required for stormwater management. Second is it depends on the technique, a lot of operation and labor required. Third, there is risk of clogging infiltration system caused by high sedimentation rates. And the last is temporary covering methods such as plastic sheeting can become torn or ripped, exposing the contaminant to precipitation and storm water runoff. Water management challenges in the Philippines. There are 10 water management challenges in the Philippines. Number 1, fragmentation of water agencies. 2, lack of science-based data and information for effective planning and decision making. 3, depletion of water availability and quality. 4, rapid urbanization and industrialization. 5, indiscriminate land use and development. 6 is increasing volume of solid waste, pollutants, and hazardous waste. 7, unabated extraction of groundwater. 8, inadequate sewerage and sanitation facilities. 9, watershed degradation. 10, inadequate water infrastructure facilities. Stormwater management in the Philippines. There is no policy on stormwater management in the Philippines. However, large corporations and industries have implemented rainwater and stormwater harvesting system to augment their water supply. The eco-efficient management of their water supply is in line with the company's ISO 14001 environmental management system, which most of them want to achieve as part of their corporate social responsibility. There is a pilot stormwater and wastewater management project that is being implemented in Cebu. The project aims to strengthen the capabilities of local government officials for the integrated planning and management of rainwater and stormwater recycling and to establish a model for integrated rainwater and stormwater recycling in selected buildings so as to demonstrate the eco-efficient approaches for water infrastructure. The project aims to promote awareness and advocacy on eco-efficient water infrastructure development in the Philippines.